Hello, and thank you for listening to Renewables, a podcast by BioStar, which aims to explore the current and future energy landscape in America.
Hi, everybody. Welcome back to another episode of Renewables. I'm your host, David Smart, our Senior Vice President of Sales here at BioStar Renewables, and very excited to welcome David Slavin, Senior Project Engineer from Burns McDonnell, onto the show today. David and I had the pleasure of meeting out in Vegas at an RNG conference, and he is an expert in hydrogen, which is relatively new to the podcast. For our listeners and viewers who have already heard the episode with Vern H2 with Bav Roy and Ted McKilveen, we talk a little bit about hydrogen storage in there, and they have a pretty amazing technology, but we haven't really looked at hydrogen from a really high level and from more of like a market level. We're going to walk through hydrogen production, how we use hydrogen, market drivers. So David, thank you so much for coming on the show and educating us about the world of hydrogen.
Yeah, thanks for having me, David.
Absolutely. So before we jump in, always want to introduce our guests, give you an opportunity, just tell us about your background, how you ended up at Burns and Mac, which is obviously a great company. I'm a Kansas City guy, and we have a lot of Burns and Mac folks here in KC. Obviously, great company. So really honored to have some Burns and Mac representation on the show. But tell us about you and your background, and then how you ended up with Burns and Mac.
Yeah, absolutely. So a little background on myself. I went to Colorado School of Mines. I'm actually sitting now in our Denver office. I was hired actually in our Kansas City office. So I spent the first 5 years of my career there locally, Kansas City. Still a big Chiefs fan, even though I have a lot of friends who are Broncos fans, but still a big Chiefs fan.
All right, we like it. I hope you wear a lot of Mahomes and Chiefs gear during the NFL season out there in Denver.
I know I still have my Smith jersey. I need to upgrade to my Mahomes jersey.
Yeah.
From there, I actually went and worked in our Southern California office. I worked a couple of years out there. And then after that, more recently, in the last 3 or 4 years, I came out here to Denver office. So my background was primarily focused. I initially was hired in the environmental group with Burns McDonnell. I was focused on doing small landfill gas projects. We were doing some small like gas to electric type facilities at that time. We were also working on a big coal bed methane project where we were taking coal bed methane and reusing it for power generation. From there, I actually moved into our natural gas group. And so I've been predominantly my entire career focused on the natural gas side of the business, working for a lot of the natural gas utilities. That's your Xcel Energies, your One Gas, your Kansas Gas Service. They deliver gas to your home for heating. Those are typically the companies I work for. I've worked for gas utilities across the country, dozens of them from the West Coast with SoCal Gas all the way to the East Coast, working with the Dominions and the Piedmonts and the Duke Energies. In the last few years, my career has actually been more focused on renewable technologies, renewable energies, really heavily on the hydrogen side. And that's what we'll spend a lot of the day talking about. I've also done a fair amount of renewable natural gas projects, taking manure and then processing it into renewable natural gas. Also still working on some landfill gas projects in the background. It's really exciting times. We always like to say in the energy industry right now, it's a very exciting time. A lot of projects, a lot of people are looking at how do we decarbonize our asset. So we're starting to see a lot of projects in this vein, things that we've never thought were technologically able to do. We're starting to see these projects come to fruition. They're making a lot of commercial sense. And now with the pass of the Inflation Reduction Act, there's even more money, there's even more incentives now to start building this infrastructure and start really making our system green, both on the gas and electric side. And so today we'll really focus around hydrogen, and we'll talk about what does that mean for people, because this is going to be a thing people are going to start seeing a lot now is this concept of hydrogen. And so we'll kind of dive into that as part of this episode.
I think I just saw this morning in some article or advertisement for a fuel cell BMW that's coming out here in a few years. So we're going to talk about there's a lot of talk about EVs, right? But we think hydrogen is a part of that sort of overarching solution as well. So let's start with production, hydrogen production. Talk about how we make hydrogen, the different ways currently, and then we'll get into who actually can use it.
Absolutely. So talking about hydrogen from, as an element, one thing to note is that hydrogen is the most abundant element in the universe, right? It's the number one on the periodic table. There's more hydrogen than there's anything else. So it's very abundant, but we've never really found a good way to capture and use it for our energy needs. We like to talk about, there's this concept of like a hydrogen rainbow in the industry, and we're actually trying to get away from that term, but it's really tied to the carbon intensity of the hydrogen. So there's lots of different ways to make hydrogen. One way that's become more popular that we're seeing a lot of benefits from is what we call electrolysis, water electrolysis. And so what we do in that case is we actually take water, which is H2O, the element H2O, we apply electricity, and through a membrane, we're actually able to split the hydrogen from the oxygen. We can vent the oxygen off. It's a safe gas. From there, we actually capture the hydrogen and we use it for different purposes, such as a fuel, some type of combustion fuel. The beauty though of hydrogen, if you look at it from like a stoichiometric equation, sort of a combustion equation, right? H plus oxygen just makes H2O. So at the end, you're just left with water vapor, or water just kind of falling out the tailpipe of your car. So it's complete combustion and without any sort of like carbon or CO2 production. Which makes it so attractive as a fuel source. That's not the only form of hydrogen production. So there's already a lot of hydrogen in some of the stuff you wouldn't even think. For example, ammonia, fertilizers, things of that nature. They already use hydrogen. So we've been producing hydrogen for decades. Most of that along the Gulf Coast region, somewhere around Texas area, where they use hydrogen for a lot of their refinery processes. That hydrogen has been traditionally produced in a process what they call steam methane reforming. What you're doing there is you're actually taking the component natural gas, which is primarily methane, CH4. You're taking the CH4 in a very high temperature process. You are actually removing the hydrogen from the carbon molecule. You're producing hydrogen gas, but then you're also producing CO2. And so that CO2 is typically just vented off and to atmosphere. So in that case, and then I'm going to kind of wrap it back around. That's where I go into kind of the hydrogen rainbow of the hydrogen economy. We'll talk about different colors of hydrogen. For example, green hydrogen, that means that the hydrogen was produced through an electrolysis, water type electrolysis. But you have to understand that means that electricity has to also be green. That's associated with it. That means like that electricity has to come from some type of solar or wind or some type of green technology, which actually creates that hydrogen. If you work your way down the hydrogen rainbow to some of the other colors, I talked about steam methane reforming. That's called gray hydrogen. So there is some sort of carbon CO2 that's actually released to atmosphere. It is less than what you would think traditionally would you just burning methane itself. There's a color blue hydrogen, which means that we actually capture the CO2 off the steam methane reforming sac, and then we actually send it down hole for capturing and to salt caverns, other ways of CO2 sequestration. That's like you're seeing now a lot in power plants. We're looking a lot at CO2 capture and sequestration technologies. And then, and a couple other colors, for example, is pink. Pink's another big color that a lot of people are talking about. That's if we use nuclear power to actually produce the hydrogen. That's good to know, right? Because nuclear itself doesn't actually have a CO2 impact, so it doesn't have a carbon intensity associated with it. It does have some type of waste product that's generated that needs to be dealt with. So for that name, it's called pink hydrogen. So lots of ways to produce hydrogen. Traditionally, one of the problems with doing, and this still kind of stands to date, is the technology wasn't really there to do water electrolysis. There was water electrolysis through the alkaline method, which is kind of like your car battery, but there's now water electrolysis through more of a membrane type, poly-exchange membrane type. And some of the problems with that is it's a lot more expensive to produce the hydrogen, right? Hydrogen produced through Green hydrogen is typically about $6 a kilogram to produce, where blue hydrogen or gray hydrogen might be $3 or $4 a kilogram to produce. So there's a cost associated with these different technologies and how to produce hydrogen. So one of the things the Department of Energy has really pushed is this goal of producing hydrogen for $2 a kilogram, and even in the future $1 a kilogram. And for your listeners, just to kind of put that into perspective, $2 a kilogram is about 3 cents a kilowatt hour, which is what you're used to buying wholesale electricity at, about 3 cents a kilowatt hour. So we got to be able to produce our hydrogen for that same price that we're producing electricity for right now, to make it viable for the market, right? Because people aren't going to be able to spend 15 cents a kilowatt hour for their electricity, especially when you're talking about wholesale prices, when they're used to buying electricity at wholesale prices for industrial users, things of that nature.
Absolutely. And prices are going up, right? That seems like across the board, cost of power has gone up quite a bit. So I think we'll talk a little bit later about kind of some of the market drivers and how we get more adoption of this technology. So you said green, blue, gray, pink. Are there other colors in the hydrogen rainbow?
There's a cyan color where we actually take the carbon black off of the steam methane reforming process. There's a turquoise color. There's just a mixture of things that are kind of in between the technologies. But yeah, we love our colors as engineers.
Yeah, very, very interesting. It sounds like we could probably do a whole episode
just on the colors of hydrogen
on the different colors, right? So, but we're going to keep it somewhat high level today. And of course, at the end, if you want to learn more, we'll make sure you can get in touch with David and ask him all the really hard questions. So let's get into a little bit though of users, who can use hydrogen. Where are they using it the most now? You kind of touched on that, but talk about, who are the biggest users and who could be the biggest users if we're able to produce it at a lower cost.
Absolutely. So, and now as we start to see that kind of cost delta, as we're able to continue to bring it down as technology advances, the next question is like, where do we use hydrogen? And that's the beauty of hydrogen, right? It really does replace our other combustion type technologies. So for example, either that be natural gas or diesel or gasoline, things we're used to using in our homes for heating, or maybe even our cars for fuel. For example, Toyota has a fuel cell electric car out right now. It's called the Toyota Mirai. They were actually able to drive it on 800 miles on a single tank of hydrogen.
Wow.
Now they drove it at really slow rates. Now normally it only rated for about 450 miles per tank of hydrogen. Why that's so beneficial? If you look at right now, one of the biggest problems for electric vehicles is that the distance that they can drive, right? And so we're kind of stuck we're at this technology impasse where we really can't get over how do we do large scale logistics, like trucking logistics, things of that nature. How do we move products across the country? If anything, what we learned from the pandemic is how important the trucking industry is to just the way of our lives, right? The way we're used to living. And what we can't do is put electric vehicles out there and have them stopping every 2 hours to recharge their battery. The other problem with that, electric vehicles, right? And then another challenge is just the amount of how they actually have to mine the heavy metals, right? It's really toxic for the environment. It's really not, a lot of people don't know the carbon footprint of an electric vehicle is actually pretty high because of all that rare earth metals that go into it. Electric vehicle, and we haven't even started to try to overcome the problem. What do we do at the end of the life of those electric vehicles? And we need to start actually looking for how to waste these heavy metals and just the weight and the tonnage associated with those electric vehicles. Something like a large truck, a semi truck that was used for hauling your goods. Now you've added a lot of weight to that truck when you moved it over to electric vehicle. So we've kind of got to this place where we can't figure out what's next. And so where hydrogen comes into play is it's kind of a hybrid of both, right? So you actually use the hydrogen in the vehicle to actually to fuel the fuel cell. So it takes the hydrogen molecule and then turns it back into electricity, right? And then the electricity then turns the motor, which moves the car. And so we're able to store this large amount of energy right there in the hydrogen compressed, very high compressed hydrogen in the tank there. And we're able then to regenerate electricity off that hydrogen, which then again moves your motor and allows you to drive. So what hydrogen does is it takes us where EV has kind of failed as far as the long-term future, and where we're kind of, we're looking for what's next. Hydrogen helps takes us to that next level as far as long distance transportation of using green fuel, right? I mean, transportation is one of the largest greenhouse gas emitters in the country, right? So we need to look, how do we move from hydrogen? We're looking at ways to reduce these greenhouse gases, right? And so this is one of those methods where hydrogen, makes a lot of sense.
Do you think that EVs will make a significant kind of capture a really significant share of the market, and then those drivers who drive EVs will ultimately get hydrogen vehicles? Or do you think that the auto manufacturers are paying enough attention to this? And like, I mean, again, I mentioned I saw BMW had a SUV fuel cell SUV that was coming out, they said, before 2025. So that's pretty soon. Or do you think it will be kind of in this early phase of adoption, more of a hybrid, if you will, combined approach where EVs make a lot of share and then hydrogen grabs a lot of share, and then they kind of duke it out for dominance?
Yeah, it is kind of interesting to watch. One of the biggest problems, right, is you have to have the infrastructure in place. The only place you can buy a hydrogen fuel cell vehicle right now is in the state of California, because the state of California is the only place that actually provides, refilling stations for the hydrogen. It's just like a gas station. You go to the gas station, you pump in your hydrogen, and you fill up your tank, and then you go on. It used to be one of the biggest, I would say, roadblocks to switching was that just the cost of hydrogen, right? Too, like you were paying about $6.50 a gallon equivalent. This is when gasoline was about $2 or $3, so it really didn't make sense to pay double the price in gallons per equivalent. Now that we're seeing that gap close with gasoline becoming a lot more expensive and the hydrogen technology is getting better, those gaps actually a lot smaller than it used to be. We actually, one of my coworkers in California, he actually owns one of the hydrogen fuel cell vehicles, right? And so, for example, Toyota has come out with them. They call the Toyota Mirai. You got BMWs coming out with them. Every major manufacturer, Ford, all those big guys, you're going to start seeing them looking at that this as part of their portfolio as another offering. And so it is this kind of debate, right? Kind of like when EV started, right? There was really no Tesla chargers. There's no way to charge your vehicles, right? And they've been investing a lot of money in infrastructure and trying to put these EV chargers across the country to help you be able to move your electrical vehicle across the country. We're going to have to see that same thing happen on the hydrogen side. Well, one thing we are starting to see is fleet vehicles, or maybe even like bus depots and things like that. They've looked at having EV in their fleets, but some of them now have also suggested that they would also have hydrogen vehicles in their fleet. So maybe doing half electric and half hydrogen vehicles in their fleet. And so as I think people start to see the interest, and it's really just over the last few years, one of the things the DOE is also helping drive, and again with this Inflation Reduction Act, right, is that this concept of what they call a hydrogen hub. And so what they've allotted is about $8 billion in money to kind of help fund some of these hydrogen hubs across the country. Now, these hydrogen hubs are different types of technology, the ones I talked about, production methods, right, with steam methane reforming or water electrolysis. And so they have those different characteristics. They'll be in different regions of the country, but the idea is to mass produce hydrogen at a single place. And then be able to distribute it across the country for use by different users. And so I think it will be an interesting tell of what we see that happens over the next 5 to 10 years, who kind of wins out. And I think for those reasons, what I explained to why EV kind of can only take us so far, I think hydrogen, I think it's a real option on the table.
Absolutely. It's really interesting because on the electricity side, sort of for a long time it's felt like, oh, we have to shift to distributed generation and lots more smaller power plants. But to hear you say that these hydrogen hubs and to be able to create a lot of hydrogen and then distribute it effectively, I guess talk a little bit about what that would take, right? Like, is there existing infrastructure to transport it well? Talk about sort of some of the benefits of transporting hydrogen, and what it really would take. And I guess so it comes from a hub then to some gas station down the street where I go fill up my car.
Yeah, absolutely. That is one of the biggest debates, and we talk a lot about it in the hydrogen economy. Is this concept of a centralized facility that produces all your hydrogen, or a very much distributed type setup where we're producing hydrogen there locally to be used at point sources? Some of the benefits of central production is you're able to reduce the cost, right? Because you're able to use less infrastructure to produce more hydrogen, ultimately driving the ultimate cost down. Also, the amount of power you have, you can be sited right there next to your hydrogen production plant. So there's a lot of benefit to having a centralized facility. Now, the next question is, say I produce all the hydrogen here, and for example, I want to say Praxair, but one of those big companies, they actually recently built a facility right there outside of California, with the concept of actually taking the hydrogen and producing all the hydrogen, but actually trucking it into California. One of the things you can do is, because hydrogen can be compressed at such high pressures, you can then put it on storage trailers and actually truck it into different states. So even if we do see that we end up having some centralized areas which actually do large scale production of hydrogen, what we might see on the downstream side of that is a lot of hydrogen trucking to these different point sources, to these different users. But we're also looking at one of the things we are looking at is using, the pipeline infrastructure within a city, or even building new pipeline infrastructure to actually to house the hydrogen and actually deliver it to these users. If we could build a centralized grid of hydrogen, kind of like we do with our natural gas network right now, the idea that we would use the hydrogen to replace kind of natural gas and some of those traditional users that need combustion fuel, especially in the heavier industrial type applications like large boilers or maybe steel mills. We're looking at ability to actually switch them over from natural gas to hydrogen as an option.
Very interesting. Is it as efficient as natural gas?
Well, that's the $1 million question. No, it's not. It's has a lower heating value than natural gas. Now, it's funny. Hydrogen as a density of energy is as good as it gets. It has the most energy per density of any molecule in our periodic table. But one of the problems with it is that it's such a small molecule that over a volumetric basis, it doesn't have that much heat associated with it. So I'll give you an example. Natural gas is about 1,000 MMBTUs per cubic feet of natural gas, where the hydrogen is somewhere around 350. So it's about a third of the energy content on a volume basis, and then what you would find in natural gas. And so that's some of the issues, right? And kind of talking about some of the other users of hydrogen, right? So one of the big users of hydrogen is power plants, right? It's a possibility that power plants could use hydrogen or some type of blend of hydrogen. A lot of our power generation right now, from a baseload perspective, or at least from a peaking perspective when renewables can't meet, is the natural gas, right? Natural gas turbines. And so one of the things that, we're even actively testing as a company right now is blending hydrogen into the natural gas at some percent blend, and then using it in the turbine to actually generate electricity. There's, some of the downfalls of that is you have to add more hydrogen in than you do nitrogen, about 3 times as much hydrogen in to get that same heat output, that same electrical output. And so that's something that has to be considered, right? Is the capacity of the system. Because it will require more hydrogen to go in to kind of offset that energy offset. But it still, it still has energy associated with it, right? It's just not as much energy as natural gas. One of the other big users is kind of looking at hydrogen right now as a fuel source is actually the natural gas industry. There's a lot of the gas utilities right now. I think S&P has reported there's 21 projects across the country that are actually looking at blending hydrogen into the natural gas pipeline distribution system and to offset the carbon emissions. So what the science is telling us, what all the research is telling us, is that we can blend about 20% hydrogen into the natural gas pipeline industry without making any major changes to the existing infrastructure. This will allow us to offset our carbon by about 7%. So just to know, it's not a one-to-one reduction because you have to make up for that heat input. So you do have to burn more fuel because of that difference in heat input, but you are able, it does give you, it steps you in the right direction to reducing your greenhouse gases.
So they can blend 20% hydrogen without having to change anything. I wouldn't have to get a new stove or a new oven.
Yeah, and you probably wouldn't even know it changed if no one didn't tell you. Some of the, I think it's worth talking about the physical properties of hydrogen, right? So hydrogen itself is 16 times lighter than methane, right? It's a very light molecule. It's very small molecule, so it likes to kind of leak out small porous areas. The thing about it though is it disperses very quickly. That the same properties that are kind of a negative are also a positive, because compared to natural gas, it actually disperses a lot quickly around the air. One thing to know also about hydrogen though, it has a lot larger flammability range than natural gas, methane that you're used to at your house. So for example, somewhere between 5 and 15% is where natural gas, the mixture of oxygen, for the flammability limit, where hydrogen is closer to like 3 to 75%. So you just get these much larger flammability with hydrogen than you do with natural gas alone. So I mean, for the users, right, on the downstream side, and that's the one thing the natural gas industry is really looking at is like, and there's been a lot of white paper and publications, is really the safety of hydrogen, blending hydrogen in the natural gas network. What we know is that at 20% blends that your boiler will, and your stovetops will burn just like you're used to seeing traditionally. So the user would have no differences. But one thing we are like doing studies on is like dispersion studies within households. If there was a natural gas and hydrogen blend leak, what the studies are showing us, and what we run these like very in-depth CFD, computational fluid dynamic models. What they're showing us is that there really would be no dispersion. Hydrogen itself would not break apart from natural gas. It would pretty much stay blended as it continues to disperse. So it's been all positive things. But what I can say is that, like your meters on your house, your regulators on your house, they're at 20% blends, it really would not make any difference.
Very interesting. That was one of my big questions. And so what about on the pipeline infrastructure? Does it, I guess it sounds like at a 20% blend, it would be fine. But as you start to blend it more and more, I guess the stove stops working. Is it harder on sort of the existing infrastructure, and what kind of new infrastructure, would it take to really commit to hydrogen?
Yeah, absolutely. So there just to understand the natural gas system, how it works, right? It's comprised of what we call transmission and distribution. I'll go more traditional source. Your transmission is your much higher pressure gas. That's how we move gas across the country, right? Right now there's 300 million miles of pipelines, natural gas pipelines in the country. There's a lot of infrastructure already in place. It's been around for 100 years, some of it. Chicago just replaced its last 1800 piece of pipe, actually. And so one of the issues, because it's such an aging infrastructure, right, there's a lot of different types of steels and older materials as part of the system. And one thing hydrogen, because it's such a small molecule, your most of your pipe, and especially at the higher pressure transmission side, is made up of what we call carbon steel. So that hydrogen actually can kind of, at an atomic level, kind of infuse with that carbon, because hydrogen itself wants to kind of break apart and join other molecules. And so what it can happen is it can actually infuse inside the grains of your carbon, and it can lead to what they call hydrogen embrittlement, which could be, so a lot of the studies we've been doing, and so for example, the Sandine National Laboratory, a lot of the national laboratories have been looking at the metallurgy of the existing pipeline infrastructure and what do different hydrogen blends do with that different infrastructure. What we can tell you based on the research is that it feels that the research in science is telling us that anything with lower grade steel, so that would be like your X52s, so that's just, again, that's the grade of steel that's in the ground. Anything X52 and below should be fine. It's not really susceptible to hydrogen embrittlement. What we find though is in like higher grade steels, especially like things on the transmission side where they're up to like the X70s, even X80s, you are going to see a lot more issues with hydrogen embrittlement. One thing you do have to be concerned about is just the age of your infrastructure if you're blending hydrogen in it. You might already have a lot of cracks and defects in your system, and again, that's a good place for hydrogen to kind of sneak into the porous and metallic structure of the metal. And so we just have to be really careful that we're really evaluating the systems before introducing hydrogen. One of the benefits on the low pressure side, on the distribution side, and where your gas utilities are, and most of your listeners, they're used to seeing natural gas, is most of that is actually plastic pipe, and plastic pipe does great with hydrogen. There's no concerns. So what we're seeing from a gas utility, natural gas utility, that hydrogen makes a lot of sense for blending in at the distribution level, kind of maybe right there at the city gate, where it kind of feeds the city, because a lot of that downstream is like plastic and low grade steels. Where it doesn't really make a lot of sense to blend hydrogen is at the transmission level and the cross-country transmission pipelines. Again, just due to the high grades of steel and the inability to control, really it's just a big bottle, right? The transmission pipeline is a big bottle that has a lot of users that feed into it and take gas off of it, including your towns and your cities like Kansas City or St. Louis or every other city along the way. If we start blending hydrogen in at that level, at the big bottle transmission level, one of the problems is we can't really control how much hydrogen gets to the ultimate user, right? And so there's going to be some cities who don't want hydrogen in their system, right? And so that has to be the choice of that local utility. So what we're seeing a lot more is actually a lot more interest to blend hydrogen on the distribution level, to actually, reduce some of their greenhouse gases and ultimately, carbon reduction technologies.
Very, very interesting. And I think we had also talked about hydrogen gas and in salt caverns, and talk a little bit about I just think salt caverns are weird and interesting, but talk about some of the use there.
One of the things when you're looking at hydrogen and the production of hydrogen is how do we store large productions of hydrogen, right? There's a few technologies out there. I think you mentioned one where you had another company come on. They were talking about some of their technology around their solid oxides. There's different ways we're looking at storing hydrogen at a mass scale. Really, the only ways that make the most sense are probably in an underground sort of cavern. What we've known is that that's traditionally how we store large quantities of natural gas. So we're very, it's a very familiar thing when you're talking about using a gaseous form, storing large volumes of a gas. One of the things though, like salt caverns versus like depleted reservoirs, is there's actually better options for hydrogen storage. One of the nice things about salt caverns is they're really dry, right? So they make great candidates for large storage of hydrogen. But if you look at like depleted reservoirs, they're kind of wet. The hydrogen wants to then mix with the water, and it wants to produce like large scales of H2S, which can lead to like corrosion. And so depleted, what we're finding is in our, we're doing a lot of research and studies around this, is that depleted reservoirs don't make a lot of good sense for hydrogen, large volumes of hydrogen storage. Now, salt caverns, those are kind of like the cream of the crop. So the more, salt caverns we can find. Now, underground storage, that's one form of storage. And the other form of storage is sometimes we use like large metal, composites, kind of like they do in the CNG trucking world, where we actually store the hydrogen at really high pressures in those type of composite tubes. And we can kind of store them above ground. We can also use large like vessels. One thing that doesn't make sense that you see, for example, we do a lot of storage in the country on natural gas. We do a lot of storage at the LNG as a liquefied source. So we have to then bring the gas down to a temperature of negative 273 degrees. Then we're able to store it at atmospheric pressure. The problem with hydrogen is you actually have to bring it down to like negative 413. And so it's just a lot of energy to cool that much hydrogen to that low temperature and maintain it at that temperature. So the liquefied form of storing hydrogen, yes, it's on the table and people are looking at, especially at those large hydrogen hubs that we talked about, those centralized production facilities. It doesn't make a lot of sense at the decentralized scale. At that scale, it makes a lot more sense to use kind of like the composite tubes and different metal structures.
really interesting. So I want to get into, as we kind of come into the back third of the segment here, I want to get into the market and how it seems that, a market hasn't been fully developed, right, for hydrogen. And that actually, I think we had talked before the show about kind of the LCFS market and how important that is to renewable gas. But ultimately, there isn't really a marketplace for hydrogen. So talk about the hydrogen economy, as you called it earlier, some of the challenges and the issues with implementing it into our everyday lives and ultimately creating a market where people can use this important molecule.
Yeah. And so that's been one of the largest struggles for the hydrogen economy, right? Is there hasn't really been a value assessed to the hydrogen molecule, right? And one thing, me and David's background, right, on the LCFS side, is that there's a value associated with a decatherm, right? There's a cap and trade, marketplace that assesses a value, and that value is then, through a system of credits, is then applied to that. And so then, that helps drive that as an industry. One of the problems with hydrogen, though, is there's really no market value for hydrogen. It's instead, and that really just comes with time. It comes with with more users signing up, with more people producing hydrogen. It's really that supply and demand curve is going to kind of come together and kind of show, hey, this is where the value of hydrogen kind of sits. One of the things that has happened, though, in the last few months since the last time we talked, is that now the LCFS program is actually seeing hydrogen as a transportation fuel as well.
Oh, wow.
So it's starting to add a value to hydrogen as a transportation fuel. So that's still all coming out really recently. We're all reading the regs and trying to figure out what is that going to do to the hydrogen economy, right? How do we get that hydrogen molecule to, into that system for then you can actually take advantage of that cap and trade system like we do currently in on the renewable natural gas side of the market. And so really, ultimately, those users and those producers, they're going to end up driving that market. But right now, none of us know. One of the things we're looking at is like a bunch of industrial users to use hydrogen, and we're telling them, hey, we think that, we're working for the producer. Hey, we think it will cost this much to produce the hydrogen. He then has to go, kind of negotiate a deal with the ultimate user of the hydrogen. Well, to produce and deliver it to you, it's going to cost us this much, but they want a return on their investment, right? So they're going to need to sell it for this much. And so that right now that's so up in the air. And it's not, there isn't a really good marketplace for it. And that's one of the things we're going to need to see really come to fruition in the next 2 to 3 years for hydrogen to really kind of have a place, because companies need to know that they can invest so much in this infrastructure to produce hydrogen, and this is what their return on their investment is going to be, because that's what ultimately drives these type of technologies and the ultimate commercialization of these type of projects.
Super interesting. And actually, I did not know that on the LCFS piece. I probably should have known that, but that's super interesting. That's low carbon fuel standard for our listeners and viewers who aren't familiar. And we have a bunch of episodes on renewable natural gas kind of earlier in the show. So if anybody's interested in learning more about the California LCFS program, you can find renewable natural gas episodes wherever you listen to your podcasts. Go find us. Talk just real quick. I think we've touched on it a little bit, but who is using the most hydrogen right now? Like who currently today is using all the hydrogen produced?
Yeah, most of the hydrogen produced in the country is used around fertilizers, right? Your ammonias, your NH3s. That's kind of your biggest user of hydrogen at the moment. Again, along kind of the Gulf Coast from a refinery standpoint, and they need to have hydrogen for a refined element. That's kind of who uses the hydrogen right now in the country. And so it'll be interesting, right? So a lot of those facilities were built kind of in the 1970s, and a lot of them are just older infrastructure, right? And so now we're starting to see all this and this isn't the first time, and I'm just going to put this out there. This isn't the first time hydrogen has has seen this kind of revitalization. Maybe this, they'll talk about in the early 2000s and the 90s, Japan was sold. They were going to do hydrogen. Everything was going to be on hydrogen. America was signing up for it. We're like, yeah, we're going to do hydrogen. This is great. And then it just kind of fizzled out, right? The technologies weren't there. The difference in energy, the cost of energy, people weren't ready to invest in this type of infrastructure. I think one of the biggest differences now is, with acts like the Inflation Reduction Act, the government sees the benefit, people are starting to see the benefit, and, the utilities, the company, the users of fuel, they're starting to see the benefit, and everyone's kind of moving towards this, net 2050 net zero goal, right? And that's kind of the big buzzword we use a lot in the industry. Is this 2050 net zero, where we're not producing any more carbon than is currently being produced right now. And that's really to kind of curb this, this greenhouse gas effect that we're seeing across our globe, right? As we kind of struggle with climate change and as we struggle. And so I think it'll be interesting how hydrogen plays in. One of the big things American Gas Association came out with, they did a white paper on how do we achieve the net goal of 2050 net zero decarbonization. And they had a great graph that they put together. And in the graph, they say 51% of that's going to be RNG, right? And then they go on to say 20% of that's going to be traditional hydrogen blended into your asset. And just like we talked about, 20% is kind of that safe number where you don't have to change out your boiler, your orifices, or anything of that nature. And that rest of that 30% is going to be methanated hydrogen. And that's one thing we really didn't hit on, is what they call the syngas, right? And what methanated hydrogen is where we actually take CO2 from some source, like let's say it's a power plant or a bottling factory, a winery, or all the other millions of places that produce CO2 in this country. And we actually take that CO2 and then we take it through a catalyst, through a methanization process it's called. And we actually take that H molecule and the CO2 molecule and we blend them together and we make methane, CH4. And then we just vent off the oxygen in the process. So they see that, that the technology is still growing there. There's a lot of, for example, the National Renewables Energy Laboratory here in Colorado, they actually have a power to gas. It's a bioreactor on their system. One of the utilities we're working with is actually trying a pilot project on one of the renewable natural gas projects where they take the CO2 and they actually blend it with the hydrogen to make methane, which again, you're able to even further your decarbonization of your technology. And actually, even achieve more results, right? Taking CO2 out of the atmosphere, which is one of the things we're looking at as an industry.
Awesome. Well, we have really, frankly, just scratched the surface here. I know we could go on, and to that end, I hope that you will come back on the show. Maybe we need to have another episode on syngas alone, because I know there's a lot of cool developing technology there. In fact, I think we have a guest coming on here in a month or two who we're gonna dig into that a little bit further with. David, really appreciate you coming on. You're such an expert in so many different things, and I really enjoy chatting with you. And by the way, Burns and Mac is also working on some just amazing projects around the country and really cutting edge stuff. So we could probably do a whole other episode on some of your favorite projects and some of the really interesting things you guys are working on. As you kind of look into the future, what excites you the most? I know you're working on all sorts of different things, but what gets you the most excited right now, in the energy space, kind of as you look into the future?
It's kind of this balance where it's like we're trying to find a way to balance the ins and outs of how we live our lives, right? We're not asking people to change the way they live. We're looking at ways of taking energy that we never thought was possible before, and how to reuse that energy in different places. One of the unique things that we're looking at right now is using hydrogen as almost a form of energy storage. So what we would do is, when renewables are really high, is we'd actually generate hydrogen from that process, right? When we're typically curtailing electricity in California because we can't use all the renewable electricity we're doing, and we're actually looking at to store the energy and then, actually releasing that back in to be used as so really a form of battery storage. One of the things we're finding is that batteries, just really aren't cost effective. It goes back to the heavy metals. So we had, we're even thinking outside the box of places that we never thought we would think. And so we've come into this, and it's a great time to be in the energy industry because we're being challenged like we've never been challenged before to come up with new innovative ideas that make sense for decarbonization. And it's really awesome. Just as myself, an environmentalist at heart, I love to see where we're going from a application. And by the time we're seeing it as consultants, that means it's been in the R&D world for 5 to 10 years. We're actually starting to see these technologies that have been in the R&D world. We're actually getting to put these technologies into installation. We're building some of the first hydrogen projects in the country. We're building some of the first renewable natural gas type projects in the country. We're doing things that we never thought were possible decades ago. So it's a great time to be in the industry.
Yeah, it's super exciting, and doing them at scale, which is really, really important and impressive. And we could definitely do another episode on hydrogen storage. I personally think that is a huge, huge part of our future success in decarbonizing a lot of industry. So this has been super interesting. Like I said, I think we could probably go on another hour. We're going to wrap it up. And I really hope you'll come back on the show and talk about some of these other topics we've covered and tell us what's going on at Burns McDonnell. Before we wrap up, how can our listeners and viewers get in touch with you, follow along online? Are you a LinkedIn guy or a Twitter guy? How can our people find you?
Absolutely. LinkedIn is always a great way. I love my friends on LinkedIn. We do a lot of publications as a company, right? We're constantly putting stuff out there, a lot of content for people that kind of follow us. So please follow me on LinkedIn, and yeah, more to come.
Awesome. Well, we will include your LinkedIn profile and of course the Burns and Mac website and all the show notes. This has been another episode of Renewables with David Slavin, Senior Project Engineer at Burns and McDonnell. To all of our listeners and viewers who tuned in, thank you, and thank you for tuning in all the time that you do. The podcast has really been growing. We're super excited about it. Make sure and click that follow button. And David Slavin, thank you again for coming on, and I hope to see you soon. The world is back busy again, going to trade shows and traveling, so I'm sure I'll be seeing you somewhere fun in the near future.
Absolutely. I look forward to it, David.
All right, take care, man. Thank you.
All right. Bye.
Hello, and thank you for listening to Renewables, a podcast by BioStar, which aims to explore the current and future energy landscape in America.